Welcome back to another Skits Tut. I am Mr. Skits, and I have something special for you today. This is actually the smoothest camera functionality as far as following the player that I have found so far, and this works great. You can kind of see that I put the script on the camera. We're going to have the actual player in this slot, and we're going to create some ticks to where you can enable it or disable it. Right now I want to be able to jump up and scroll upwards, so I left this one unticked, and you'll see that when you get to the edge of the screen to either side that the camera will stop and the player will be able to keep on going, and then it'll pick back up when it rolls the other way. And you got to set these coordinates custom. The way that I did it is I walked the player over, and when the camera was showing any of the background behind this, I kind of scooted it over to where it lined up perfectly, and I copied the X coordinate and I pasted it in here, and I did the same thing this way, and I got the coordinate for here and I pasted it in there. Personally, my minimum Y, which is the bottom down here, if you can see where the camera is lined up, it was exactly at the 0 because my player is at the origin. When I started my program, I had everything set up to the 0, 0, 0. Now I'm going to paste this code into a Unity forum. This is kind of also helping somebody named Silent Stalker or something, Silent Stabber. But I'm gonna paste the code in there so you can actually copy and paste this instead of typing, which typing is better for you when you're learning, but I'm gonna give you a break this time. I will go over a few things. This is actually how I set the headers up for the player's transform, the offset fields. This is the headers that you're seeing: camera offset, player transform. That's actually how you do that. So I started everything as false so that it wouldn't automatically happen. You actually have to tick it when you're inside, and we initialize it that way. Started everything at 0 so that you can customize exactly the point, because if this was true, then the camera would automatically take these values and it would not follow the player most likely. It might even look weird. Started a vector 3 for the camera position, and a vector 3 I never really explained, but it's 3 sets of coordinates. A vector 2 would be for 2D X and Y. The vector 3 will be the Z. I also set a camera velocity, and I set it to vector 3.0, which would be the equivalent of So that's basically what vector dot 0 is, and if it was vector 3 dot left, then this would be a -1. The X would be -1. If it was right, then this would be a +1, and the same thing goes for each axis. It's just three-dimensional rather than 2, but it works in this code even though this is 2D, and I'll show you how below. I give it the camera a little bit of a lag, so that when the player walks off, it takes this long before the camera decides to follow the player. so you can get ahead of it a little bit. Normally with cameras you'd want to use a late update. The fixed update is better for calculations and physics and stuff like that. However, this works perfectly fine and I'm happy with it. I really am. We actually initialize the camera position by the player's position, and then we grab the Z position, and we just pretty much make sure that the Z is on the same axis as the player, so that it follows them and it stays at the same distance. Now, when we're moving left or right, if both are ticked and both are true, so right now max X and min X is true, it's going to run this code right here. But if you only tick the minimum Y, I guess I was doing, oh yeah. So if you only do the minimum X, it's going to run this code. And you can faintly see the difference is that it calculates the minimum X set coordinates and then the max X set coordinates. Whereas here, it's only going to do the minimum X set, and it's going to just read the player's position on his X axis. And here, it does just the opposite. See, the player position X is here and the max set. And this is exactly for the Y. We do the exact thing. You can just copy this and just change everything to, well, I'm going to give you the script so you can just copy it anyway. But everything is the same except for the Y coordinates. And when we actually update the camera's position, this is the magic. Since the script is on the camera, we don't need to put camera transform. No, it's just the transform position is going to equal the vector 3, and then we do the smooth dampening on it. We're going to get the current transform position of the camera. We're going to find the camera position. We're going to reference the camera velocity, and then we're going to consider the camera lag timer. So if you don't remember the camera velocity, it's just vector 2 0. So it's just referencing that. And then the lag timer, that's what's going to make it follow. So it starts off as 0 and boom, it's going to kind of roll over a little bit. And that's really all there is to it. I've been really laggy, so I'm going to try and run the video to give you an indication of what this actually looks like. And if you watch right here where the camera is, you see this little circle right here. You see how the player's ahead and then the camera catches up. And you notice how the camera's always there, but watch when I get to the edge. See, as soon as I get right here to where it's lined up, he can go all the way to the edge, and then the camera picks back up again. The camera is not moving like it's supposed to when he jumps, and it stops again. So I don't know whether or not that lagged up, but I'm going to go ahead and I'm going to move the player up so you can see that the camera will follow the player as he goes up in the same fashion. But once he gets down to the bottom, the camera will stop because I have the